Okay, in this video I'm going to have us begin looking at the trig functions. First thing is a definition. It says that an angle is in the standard position if the vertex is at the origin and the initial side lies along the positive x-axis. Okay, so I've got a picture there of an angle, what it would look like if it were located in the standard position. This is angle theta. Another definition for an angle theta in the standard position, we're going to let point P have coordinates x, y, be a point on the terminal side of this angle here, and that is also a point that's going to lie on the circle x squared plus y squared equal r squared. Okay, so I've got a picture of point P. Now to get point P, you're starting at the origin and you're going x units to the right and y units up. So point P is going to have coordinates x, y. The radius of this circle is a radius of r units, and the circle is centered at the origin, okay, since h and k are both 0. The way that we define sine of theta, here's theta, is we want the opposite side over the hypotenuse, or y over r. Cosine theta is defined to be adjacent over hypotenuse, or x over r. Tangent of theta is defined to be opposite over adjacent, or y over x. X can't be 0. Cosecant of theta would be the reciprocal of sine of theta, so you're just going to switch the numerator and denominator. Secant of theta is the reciprocal of cosine of theta, so cosine of theta is adjacent over hypotenuse. Secant of theta would be hypotenuse over adjacent. X can't be 0. Okay, y can't be 0 up here for cosecant theta. And then cotangent theta is the reciprocal of tangent theta. You're switching the numerator and denominator, and so we want opposite over adjacent. Y can't be 0. Okay, these are the 6 trig functions to know. Here's what the terminology that I was using: opposite, adjacent, hypotenuse. Okay. When you've taken trig before, perhaps you were told this SOHCAHTOA phrase, okay, which is just kind of a way to remember sine is sine of an angle is opposite over hypotenuse, cosine of an angle is adjacent over hypotenuse, tangent of an angle is opposite over adjacent. Okay, now in this picture, angle theta was an acute angle because it measures less than 90 degrees. Just a note, theta does not always have to be acute. You know, it could be a negative angle or it could be an obtuse angle. The same 6 trig functions would still apply. So the point of that is to say that you might have a triangle in some of these other quadrants, and the values of these trig functions might be a negative. We'll see that a lot, actually. Okay, now in the last video I was talking about major angles and minor angles. The major angles are 0 degrees, 90 degrees, 180 degrees, and 270 degrees. The minor angles would be all the other angles that are not the major angles. So let's use the trig functions now to find the results for the major angles. And in this problem here, in these calculations, it's going to be easiest for us to just take the unit circle that is a circle of radius 1. Okay, so I've got several circles of radius 1 drawn, and point P located at a certain spot here on the circle, okay, which is going to also lie on one of the 4 major axes. So I've got the angle that we're talking about in degree measure. What that would also look like in radian measure, okay, so 90 degrees is the same as pi over 2 radians, 180 degrees is the same as pi radians, 270 degrees is the same as 3 pi over 2 radians. And let's compute sine of 0. Okay, well, on the 0 degree axis, point P would have coordinates 1, 0. Now, sine of an angle is defined to be y over r, and so y is 0, r is 1, 0 over 1 is 0. Cosine of 0, cosine of an angle is defined to be adjacent over hypotenuse, And so the adjacent side here, well, that's also the same as x over r. X is 1, r is also 1. 1 over 1 is 1. Tangent of 0, tangent of an angle, is defined to be y over x. Y is 0, x is 1, 0 over 1 is 0. Cosecant of 0 would be the reciprocal of sine of 0. Sine of 0 was 0 over 1 is 0. Okay, so I'd switch the 0 and the 1, and that's going to be a problem because I know I can't divide by 0. So cosecant of 0 would be undefined. Secant of 0 would be the reciprocal of cosine of 0. Cosine of 0 is 1 over 1, which is 1. If you flip the 1s, that's not going to change anything. You're still going to have 1 over 1 is 1. So secant of 0 is 1. Cotangent of 0 is the reciprocal of tangent of 0. Well, tangent of 0 is 0 over 1, which is 0. When you flip the numerator and denominator, that's going to be a problem with division by 0. So cotangent of 0 would be undefined. How about 90 degrees, or pi over 2 radians? So sine of pi over 2, now here's the pi over 2 axis, or the 90 degree axis. Point P then would have coordinates 0, 1. Sine of pi over 2, a sine of an angle is y over r. Y is 1, r is 1. Again, I'm using the unit circle here. 1 over 1 is 1. Cosine of 90 degrees, a cosine of an angle is x over r. X is 0, r is 1. 0 over 1 is 0. Tangent of 90 degrees, tangent of an angle is y over x. Y is 1, x is 0, and there'd be a problem with division by 0 there, so tangent of 90 degrees is undefined. Cosecant of 90 degrees would be the reciprocal of sine of 90 degrees, so instead of it being y over r, it's going to be r over y. Both of those are 1, so 1 over 1 is 1. Secant of 90 degrees would be the reciprocal of cosine of 90 degrees. So instead of it being x over r, it's going to be r over x. X is 0 though, so we know we can't divide by 0. We'd have something that's undefined. Cotangent of 90 degrees would be the reciprocal of tangent of 90 degrees. Now tangent of 90 degrees is undefined because we know we can't divide by 0. 0 would be in the numerator. When you calculate cotangent of 90 degrees, it'd be x over y. X is 0, y is 1. 0 over 1 is 0. Okay, and then move on to 180 degrees. That's the same as pi radians. Sine of pi, here's my unit circle for when you're on the pi axis. Point P has coordinates negative 1, 0. So sine of pi, the sine of an angle is y over r. So y is 0, r is 1. Sine of pi is 0. Cosine of pi, cosine of an angle is x over r. X is negative 1, r is 1. Negative 1 over 1 is negative 1. Tangent of pi, tangent of an angle is y over x. Y is 0, x is negative 1. 0 over negative 1 is 0. Cosecant of pi would be the reciprocal of sine of pi. So it's going to be r over y. We can't divide by 0, right? And by the way, notice how I'm not writing anywhere 1 divided by 0 or negative 1 divided by 0. I see students sometimes write that down and then they say negative 1 divided by 0 is undefined. Don't ever do that, okay? Because why we're saying that it's undefined is because you can't divide by 0. Like we never want to write this down because division by 0 is not allowed. Okay, I sometimes even see my calc students do that, and that's obviously a wrong thing that you want to do. Okay, division by 0 is not allowed. Secant of pi would be the reciprocal of cosine of pi. So it's going to be r over x. R is 1, x is negative 1. 1 over negative 1 is negative 1. Cotangent of pi would be the reciprocal of tangent of pi. It's going to be x over y. we can't divide by 0, so cotangent of pi is undefined. Okay, and then 270 degrees is the same as 3 pi over 2 in radian measure. Here would be the 270 degree axis. Again, we're working with the unit circle. Point P would have coordinates 0, -1. So let's see here. Sine of 270 degrees, sine of an angle is y over r. -1 over 1 is -1. Okay. Cosine of 270 degrees would be x over r. X is 0, r is 1. 0 over 1 is 0. Tangent of 3 pi over 2 is a tangent of an angle is y over x. X is 0. We know we can't divide by 0, so that'd be undefined. Cosecant of 3 pi over 2 would be the reciprocal of sine of 3 pi over 2. So instead of it being -1 over 1, it's going to be 1 over -1, which is still going to give you -1. Secant of 3 pi over 2 would be the reciprocal of cosine of pi over 2. There'd be a problem with division by 0 there, so that's going to be undefined. And cotangent of 3 pi over 2, that'd be the reciprocal of tangent of 3 pi over 2. Tangent of 3 pi over 2 is undefined, but if you switch the numerator and denominator, 0 would be in the numerator. It's going to be, so x over y. X is 0, y is -1. That'll give us 0 there. Okay. Now, ideally, and we're going to talk about other angles here in the next video, but ideally, you know, these basic angles, these major angles, would be something that we'd like to memorize. The values, like ideally we wouldn't want to have to run to a chart every time and look up answers that we should know, especially for calculations that are going to come up over and over and over again. At some point we would want to know the values. Okay, so that's something to keep in mind. Of course, like anything else, the more you practice, the better you get. But that would also apply to some other angles here that I'm going to talk about in the next video. Okay. And why don't we go ahead and stop this one right here.